1, polynomials, and we're going to be adding and subtracting polynomials. This right here is a polynomial, and this right here is the constant, and you have to find the degree, and how you find the degree is you look at each term, and each of these right here are a term, and you have to find out which ones, when you add their exponents together, have the highest value. So if I look at just the degree of this term, I have 4 plus 2, which is 6. So this would have a degree of 6. Here I would have 3 plus 1, and 3 plus 1 is 4. This one would have a degree of 1, and this one would have a degree of 0, because there is no x or y value. So you would know that your degree for this polynomial is 6, because that's the highest power when you add them together. So the degree for this one would be 6. Example number 1. If I gave you x minus 3x squared plus 8 plus x squared minus 2 plus 4x, you would need to combine like terms in order to add or subtract this equation. So I would look here, and I would start with the biggest exponent value, which is x squared. And I know that these are like terms because they both have an x squared. And really what's in front of the x squared here is a positive 1. So I'm going to have negative 3 plus positive 1, and I have negative 2x squared. Then I can look at my next one, which would be x. And I would have 1x plus 4x, which is 5x. And then I would have 8 plus, or minus actually, 8 minus 2, which is 6. So now I've combined all my like terms, and if you notice, I didn't change the exponents. You're not changing the exponents when you're adding or subtracting. You're only looking at the variable in the front. I'm sorry, the number in the front of the variable, the coefficient, in order to add or subtract. You want to make sure that it's in what's called descending order. Descending order, you're looking at alphabetical order. And then you're putting alphabetical order from greatest to least exponent value. So after you combine like terms, you want to make sure it's in descending order. So you would say, okay, it needs to be in alphabetical order. Well, there's only x's, so you don't have to worry about the alphabetical order for this one. But you need to make sure it's from greatest exponent value to least. So that's why I have x squared, then I have x to the first, and then I have nothing. So this one is in the correct descending order already. What if I gave you x to the third, y to the third, minus 6xy to the fourth, plus 2x to the third y, minus x to the third, y to the third, plus 3xy to the fourth, minus 4x squared y. So you look at this equation, and you would combine like terms. And when you look at the variables, they have to have the same powers in order for them to be like terms. So let's look at this one right here. We're looking for an x to the third and a y to the third. Well, that one doesn't work, that one doesn't work, but this one right here does. This one doesn't work, this one doesn't work. So you're just looking at these. What's going to happen to those? Well, this is really an imaginary one, and this is really an imaginary one. 1 minus 1, they go let's look at this one right here. We have x to the first power, y to the fourth power. So when we look here, this one is the same. So we have negative 6 plus 3, which is negative 3xy to the fourth. When I look here, I'm looking for another x to the third y, but I can't find one. So I'm just going to leave it alone and write it down here by itself because it didn't have any terms to add it to. And then you have the last one right here. Again, doesn't have a partner, so you go ahead and just write it down. Now you need to make sure that this is in descending order. So alphabetical order would be you're looking at your x's first. So when you write this, you are going to look for the highest exponent value for x, and that is x to the third. So I'm going to have 2x to the third y, and then I look and the next one is x squared, so I'm going to write this term down, and the next one is just x. So even though this is y to the fourth, you had to do your alphabetical order first, which was x. X comes before y in the alphabet. Now let's practice finding the degree. We simplified the equation and we combined like terms, but now we have to find the degree. So again, you're going to look at each term, and the degree for the first term is 4. It's a terrible 4. 2 and 1 is 3, and 1 plus 4 is 5. So my degree for this is going to be 5. Example number 2. The directions say to add. It's going to give you two equations, or two polynomials. 2x squared minus 3x plus 5, and x to the third minus 5x squared plus 2x minus 5. So you are going to add these two polynomials together, so you're looking for like terms. So the biggest one is x to the third. That's the highest power, and there isn't any partners for it. So we're going to have x to the third first, and then we know that x squared comes next, so I have a 2x squared and a negative 5x squared. When you do 2 minus 5, you get negative 3. And again, I'm not changing my exponents, only the number in the front, the coefficient. Then I have a negative 3x and a positive 2x, which is a negative 1x. And 5 minus 5 is 0, so you don't write anything. Now we got to make sure that this is in descending order. Well, there's only x's, so alphabetically works, and it's 3, 2, 1, so we know that we have it in descending order from greatest to least. I'm going to do 2 more examples and then we're done. Okay, so example number 3 is a subtraction problem. And it is going to ask you to subtract 2x squared minus 3x plus 5 from x to the third minus 5x squared plus 2x minus 5. Whenever it says subtract from, it means that you are taking x to the third minus 5x squared plus 2x minus 5, and you are subtracting 2x squared minus 3x plus 5. So you kind of have to rewrite the equation, so the second one goes first and the first one goes last. Now, if you also notice, I put it in parentheses. The reason I did that is because you're not just subtracting 2x from this whole thing, you're subtracting the negative 3x and the positive 5. So what you want to do is distribute your negative. So you're going to have negative 2x squared plus 3x example. So I'm going to look, I have an x to the third and an x squared, so those are not the same. So I'm just going to have an x to the third by itself. Then I have an x squared and an x squared, so negative 5 and negative 2 is negative 7x squared. I have a 2x and a 3x, which is a 5x. And negative 5 plus negative 5 is negative 10. So now you look to see if this is in descending order. Well, I have x to the third, x squared, x to the 1, and nothing. So this is in descending order. And now I have to find my degree. Well, you're looking at each term and finding the highest exponents when you add them together. Well, there's only one variable, so x to the third is obviously the highest power, so your degree is 3. Example number 4, this is going to be 2y, x times the quantity 2y minus 3 plus 4x plus 2y minus 3y times x minus 1. With this one, you want to go ahead and distribute your numbers before you start combining like terms. So I have x times 2y is going to be 2xy, and I'm putting it in alphabetical order. X times negative 3 is negative 3x. 4 times x is 4x. 4 times negative 2 is 4 times positive 2y is 8y. And negative 3y times x is negative 3xy. And negative 3y times negative 1 is a positive 3y. So now you look and you're going to combine like terms. I have an xy right here, and I have an xy right here. So I have 2xy minus 3xy is negative 1xy. Here I have a negative 3x and a positive 4x, which just gives me a positive x. Here I have 8y and 3y, which is 11y. So now I'm going to write this in descending order. And it's hard because you have two variables that are x's. So you always go with the solo one. So this is going to be x, and then it's going to be minus xy plus 11y. And so they're both powers of 1, however, you just put the solo one first for descending order. Then you have to look at the degrees. And when you look at the degrees, you're looking at the highest value for the exponents. So here you have a value of 1, and here you have 1 plus 1, which is 2.